So our goal is to put the pivot into the correct position, and to do that we need 2 pointers, first and last. First starts from the beginning, last starts from the end. Then first is going to right direction, last is going to left direction. So algorithm is we're gonna keep until first is smaller than or equal to last. Very first step is find the first position. Find the wrong position for first. So first should be smaller than pivot. So if first is pointing the bigger than pivot, that means wrong position. So first is pointing index 1. Then if first found the correct position, now it's time to find the last position. For the last, we also find wrong position for last. So there is a rule. First is less than or equal to pivot. Last is greater than or equal to pivot. So if last is greater, one is not greater than or equal to pivot, so last stop. So both found the wrong position. If we found the wrong position, so third step is swap first and last. If you swap first and last value, now you can see they are at the correct position. Now first is smaller than pivot, last is greater than pivot. It guarantees when you swap first and last. So whenever you swap first and last, automatically increase first by 1, automatically decrease last by 1. Then ABC is done, so go back to the checking. First is less than or equal to last. So keep doing. First, 3 is not the wrong position because 3 is smaller than pivot. So first we'll move. Then 8 is wrong, so it's not smaller. So first stop at index 3. How about the last? 6 is bigger, so last will move. Then 2 is not bigger than pivot 4, so last will stop. Then we are going to swap first and last again, 2 and 8. Then first will increase by 1, last will decrease by 1. Still less than or equal to, so find the wrong position, wrong value for first. So first is 7 is greater than pivot, so it's wrong, so first stay. How about the last? 7 is greater than pivot, so last will move. Then 2 is not greater than pivot, so last stop. Now, if you look at the number 1 condition, now first is not less than equal to last anymore. That means number 1 is done. Then there's a 2 step, number 2. Now swap pivot and last. If I swap pivot and last, the next time the data will be 2, 4 is swapped. Then 1, 3, 7, 8, 6, 5. Now pivot found the correct position. Left side of the pivot is smaller than pivot. Right side of the pivot is greater than pivot. If I found the first pivot's correct position, we say pass 1 is done. We are going to analyze. To do the pass 1, how many times did I compare? I'm going to count with the green color. First time when the first was at the index 1, compare 1 time. Then last stopped at 7, so compare 1 time. Then after swap, first compared with 3 and 8, so 2 times. Last compared with 6 and 2, so 2 times, so 4 more times. Then swap. Then first compared with 7 and 4, 1 time. Last compare with 7 and 4, 1 time, so 2 more times. So there are total 8 times comparison. We count only the comparison with the pivot, not comparison with the first and last. So to do the pass 1, we had 8 comparisons. Now from the pass 1, we are going to do only left sub list. Only left side we are going to do. After left side is done, then do right side. So I'm going to restart. Pivot is the first data because we set up as this way. Then there is a 2 pointer, first and last. Last is the end of the sub list. And first is 1 more than pivot. Now I'm going to find the position. First is less than or equal to last, so find the wrong position for first. 1 is smaller than 2, so first will move. 3 is not smaller than 2, so first stop. And B, find the wrong position for the last. 3 is greater than 2, so move. You don't have to compare the value because first is not less than or equal to last, so stop comparing. So actually in the past one, first compared with 1 and 3, so twice. Then last compared only one time. Then first and last already swapped, so step 1 is already done. Now step 2, swap, pivot, and last. So when I swap, pivot, and last, now I see 1, 2, 3, 4, then 7, 8, 9, 6, 5 is still there on the right side. So after first pass, 4 found the correct position. After second pass, what we say is the last position. Last is the position we say set for pivot. So 2 found its correct position. Then pass 2 is done. Now it's going to do the left sub list. In this case, the setup is pivot. Then first will be 1 greater than. Then last will be end of the. Oh, they already crossed. So we don't do anything. It's just done. Then third time, without swapping, without comparison, it is just fixed. Then if I go back to the 2, 2's right subset, right sublist is 3. It is already. Sorry, this is the same thing. Pivot is index 2. Then last is pointing this. Then first is pointing pivot plus 1. So they already crossed out. So it is done. So that is number 4. So actually, pass 3 and pass 4 are done here without changing any data, without increasing any number of comparisons. There were 3 comparisons between pass 1 to pass 2. Now, I go back to the number 1. From the first fixed position, now right side is the another sublist. When I work on this one, it's gonna be pass 5. Then, if I restart, I start from the pivot at index 4. Then my first is starting from index 5. My last is starting from the index 7. First is less than or equal to last. So step A, find the wrong position for first. Yeah, 8 is not smaller than 7, so first stop. And last, 5 is not greater than 7, so last stop. Then swap those 2. Then first increase by 1, last decrease by 1 automatically. That is just step C. Then first and last is first is less than or equal to last. That is true. So find the wrong position for first. 6 is smaller than first, smaller than pivot. So first will move 1. Then first is less than or equal to last is not true. So stop. So I compared only 1, 2, 3 times at this step, this pass. Then I'm going to swap because the first and last cross, so step 2. So swap pivot and last. So when I swap pivot and last, it's gonna be 6 here, then 5, 7, 8. So last is the pivot's final position. So this is the fixed position. So 7 found its correct position. That is number 5. So this is after pass 5. Pass 5 data will be 1, 2, 3, 4, 6, 5, 7, 8. But 1, 2, 3, 4 are all fixed. Only not fixed part at current position is left side of the 7, right side of the 7. So now I'm going to send another sublist which has 6 and 5. Then I'm going to restart. Pivot is now 6. Then first is 5 and last is also 5. Find the first position, 5 is smaller than 6, so first we'll move 1. So there's one comparison. Then they already crossed, so do not compare anymore. Just one comparison. So there was 3 comparisons from here, then just one comparison here. Then step 2, swap pivot and last. So I'm going to swap pivot and last. Then now 6 got the correct position. That is after pass 6. Then 6 is the recent one fixed, so go to the left side of the 6, that is sub. Then this one at the first and last cross, so it is just done. Then go back to the 6, there's no right subtree, sub list. Then go back to the 7, and there's a right sub list, that is 8. Also 8, pivot first, last already, so no comparison, just fixed. So this is solid. So actually, when I work on 5, that is past 7. When I work on 8, that is past 8. So there were total 8 passes for 8 data. So n passes are there. And each pass, how many comparisons were there? So first time 8, 3, 3, 1, and the last time at here, only first compared 1 time, so there was another one. So 11, 14, 16 comparisons. We can think about this one as big O efficiency, as big O and log n.